This narrative is a character string generated by an AI language model, statistically arranging words, and its truthfulness has not been verified. Such outputs without basis are called hallucinations. While confabulation more accurately reflects reality than hallucination, we follow at a time. Therefore, the content described has no relation whatsoever to any real persons, organizations, nations, or events.
All right, welcome. Today we are diving into a genuine medical mystery. We're talking about a pill that millions of people take, probably without a second thought, but it has this bizarre secret. This is the incredible story of how one single drug can be both a powerful medicine and a harmful poison inside the exact same body.
So this is the big question we're tackling. How can one little chemical compound be a hero in one part of your body and a complete villain in another? It's a real paradox, and it kind of challenges everything we think we know about how medicine is supposed to work.
And at the heart of our story is this guy, Lansoprazole. You've probably heard of it under brand names like Prevacid. It's what's called a proton pump inhibitor, or a PPI, and it's super common for things like heartburn and acid reflux. On the surface, it seems totally simple, totally safe, but it's not at all. And here it is, the core of the mystery, the Lansoprazole Paradox. In the esophagus, for people with a condition called eosinophilic esophagitis, this drug is an absolute lifesaver. It doesn't just soothe symptoms, it actively heals inflammation and reverses scarring. But get this, in the colon, the same drug is linked to causing severe inflammation and scarring. Heals scarring in one place, causes it in another. How on earth is that possible?
Okay, to figure this out, we need to put on our detective hats. Let's go to the first scene of the crime, the esophagus. This is where Lansoprazole looks like the undisputed hero of the story.
So the facts here are rock solid. For folks suffering from this really nasty inflammatory disease, Lansoprazole isn't just some pill to make them feel better. It's a frontline, go-to therapy that doctors prescribe specifically to undo the damage to the tissue. And you know what? It works. It works really, really well.
So the question is, how does it pull this off? Well, our first major clue is something called the STAT6 pathway. Just think of this as a major communication highway inside your cells. When that highway has way too much traffic, when it gets overactive, that's what directly leads to all the inflammation and scarring. So, this brings us to what we can call the hero theory. And it sounds perfectly logical. Step 1, you take the pill. Step 2, the drug gets to your esophagus and acts like a massive roadblock, shutting down that busy STAT6 highway. And Step 3, with the inflammatory traffic jam cleared, everything calms down and the tissue actually starts to heal. See? Simple, clean, makes perfect sense. Case closed, right?
Well, not so fast. This is where we find the first major crack in the case. If the drug's fundamental job is to block STAT6, then shouldn't it be doing that everywhere it goes? Why wouldn't it also be putting out inflammatory fires down in the colon? This one question turns a simple story into a really complicated puzzle.
So now, let's head to our second scene, the colon. Because down here, our so-called hero starts to look very, very different. In fact, down here, Lansoprazole looks a lot more like the prime suspect.
Okay, just look at that number. It is absolutely staggering. This isn't just a tiny, maybe it's a coincidence kind of thing. Major studies show that if you take Lansoprazole, your odds of getting this specific damaging inflammatory condition in your colon shoot up by nearly 16 times. That is a massive, undeniable link.
So what's the deal here? Well, the main clue points to a completely different character, a molecule called TIMP1. So your body has this awesome little collagen cleanup crew that's always clearing out old tissue. TIMP1 is like the brakes on their cleanup truck. If you get too much TIMP1, the brakes get slammed on and all that old collagen just piles up.
And that gives us our villain theory. Step 1, you take the pill. Step 2, for some unknown reason, when it gets to the colon, the drug makes TIMP1 levels go through the roof. Step 3, the cleanup crew gets shut down and collagen builds up and up and up, creating this thick, scarred layer that damages the colon. This is literally the definition of fibrosis. Okay, so let's just stop and take a breath. We now have two perfectly reasonable science-backed stories for the same drug that completely and totally contradict each other. In the esophagus, it's an inflammation blocker. In the colon, it's a fibrosis creator. It's time to put these two stories side by side and see where it all falls apart.
So let's look at our evidence board. The clinical result? It heals fibrosis up top and causes it down below. The proposed mechanism? It seems to turn off the STAT6 pathway in one place, while turning on the TIMP1 pathway in another. And that leads us to the core logical breakdown. Is this drug, at its heart, an inhibitor or a promoter? A single chemical can't be both. That's not how chemistry works. It's a logical impossibility.
So, how in the world does the medical community try to explain this away? Well, this is where we start to get into what you might call the official alibis, the explanations that are supposed to make this all make sense. But as you're about to see, they might just create more questions than they answer.
Yeah, the official explanations usually fall into one of three buckets. First, there's driver switching, which is basically the idea that different pathways are just in charge in different parts of the body. Then you have tissue specificity, which is kind of a black box argument. It just says, well, the cells are different. And finally, there's epigenetics, which can sometimes feel like a handy get-out-of-jail-free card for any biological puzzle. The problem is, none of these really gives us a single, cohesive theory that solves the paradox.
In fact, the source material we're working from here is incredibly blunt about these theories. It calls the collection of all these after-the-fact explanations, quote, a sophisticated excuse. It's basically a very smart-sounding way to cover up a huge gap in our knowledge, not a real solution to the puzzle at all.
So, if the alibis are just sophisticated excuses, what's the real verdict here? What does the Lansoprazole Paradox actually teach us? Well, the conclusion is actually pretty simple, but it's also incredibly profound, and it says a whole lot about the limits of what we currently know. The paradox really shines a bright light on a fundamental truth. We can't yet look at a drug's chemical structure and predict the full, complete effect it will have on a system as insanely complex as a human being. The hero story and the villain story are both true observations, but that single unifying plot that ties them both together, we're still looking for it. And here's the ultimate irony in all of this. After all the molecular biology, all the advanced science, we are forced back to an answer that sounds almost pre-modern. Why does lansoprazole heal one part of the body and harm another? The only truly honest answer we have right now is because the location is different. It's a statement of fact for sure, but it is not the deep, satisfying why that science is supposed to provide.
You know, the Lansoprazole Paradox isn't just some weird little quirk about one drug. It's a huge reminder that biology is just endlessly, fascinatingly complex. And it really makes you wonder, doesn't it, what other medical truths that we take for granted are actually just hiding a much deeper, much more interesting mystery waiting to be solved. Thanks for digging into this with me.